Okay, this is Algebra 2, Module 3, Lesson 20. And it says express g of x is equal to a negative log base 4 2x. And then we're putting in the general form of the logarithmic function. And then we're going to identify a, b, h, and k. So let's just manipulate this and put it back into the general form. And, excuse me, we can break this apart as negative log 4 base 4 2, and then we would have minus, because we've got to keep it minus because it is a negative x, so let's keep it as a negative here. Okay, that can get a little confusing because now if you were to put those back together, you have to be careful to not make that a positive log. And I really can't tell you how a good way to do that, honestly. Maybe you could go ahead and say leave it as a plus log 4x, and then when you do this log base 4 to 2, then change this back to a negative. It's just hard to know when to, it's just however you want to do that, I guess. However you feel more comfortable. I would just go ahead and write it like that so I wouldn't forget it the rest of the way. All right, so let's go ahead and do log base 4 2. So to what power of 4 is 2? And that would have to be a square root of 4 gives us 2. So now that's going to equal, excuse me, a negative 1/2. And there's nothing we can do with that log 4, so let's just write log 4x. And that's it. Now we would just simply talk about what our A, B, and all that is. So what is A? And be careful here and don't say that, oh, there is no A, because there is an A. Okay, right here in front of this log is a negative 1. Okay, here is the negative 1. Now, B, we have a base stays the same, 4. Okay, then we're going to have an H. Well, there's nothing in the H, so we're going to make that as a 0. And then what's left? Our K. Now, we're used to seeing K at the end of the equation, but here it's at the beginning. It doesn't matter because it's commutative property. So there is our 4 variables there. Okay, now let's talk about it. What's happening here? And I would probably go back to the original form to talk about it. No, it would probably be easier to do it from the generic or the general logarithmic form. Probably be better to look at this one. Okay, so let's look at it. Josh said, why would you do that? Why would you look at the original? It doesn't matter. It all depends on how you can read it better. I mean, it's just whichever way you want to read it. Probably because of this 2 here and it being a base 4, that's a little bit harder to see. That's a 1/2. So I probably would just do it from the general form. So let's do that. So if we look at that, what does the negative 1/2 tell us? Since it's at the beginning, let's go ahead and talk about that. Well, that's a vertical translation, and that's going to be down 1/2. Okay. And then the only thing else that we have right here is this negative log. What is a negative log? That tells us that it's going to reflect over to x, right? And that's the only other thing that's happening with this. So that's it. Okay. Now let's graph it. And once again, just plug in as x, and whatever you get, that's your ordered pair. So maybe let's do since we got two different graphs here, we're going to do G and H. What is it? So H is just it's your parent function basically. So let's go with G of x and H of x, and then this is just going to be our x. So let's start with let's go with just starting with like a 1/2, and then let's do a 0, 2, and 4. Let's see what those turn out to be. So if I plug in a 1/2 4x, okay, I would get negative log 4 times 2 1/2. Well, that's just a negative log 4 1. So what would you get? 1/2 would be 0. So and actually that's not a good 1/2 because those are in increments of 2. So let's move this closer to here. And we know this is going to be like something way up here. We're going to approach the x, or we're going to approach the y but never cross it. Alright, so there's your 1/2 of x. So this is 0. If we plug in a 0, what do we get? If we plug in a 0 for x, we get log 4 to the 0. How do we get a... Oh, I didn't want to do 0. We know we can't get a 0. Sorry. I wanted to do 1. Let's do 1. So how would you get... I gotta do this correctly, don't I? Here we go. This is a 2. Okay. So log base 4. How do we get it to be a 2? Well, that's going to be a 1/2, right? Log base 4 2. That would be 1/2. Now we have log 4 because it's 2 times x, and that would be 1. And log 4 times 2 is 8. What power of that is 8? That's really not a good one. I don't know, that's going to be close to 1.7 or something like that. Okay. Now let's just go to G of x. What is log base 4 of x? So if it's 1/2, how are we going to get... Oh, and you know what? We got to flip these. Those are all going to be negatives. Sorry, forgot about my negative out here, guys. Make sure you're watching out for that. You got to change that to be a negative. Did anybody catch me on that? Somebody said something. What did they say? Nope. Okay. Be careful with that. You got to watch your negative there. So we're going to be coming down here something like this. And it'll be graphed something like that. Now this is G of x. Now if we go back to our original parent function here of H of x, we would have 1/2. How do we get log base 4 to be 1/2? Well, that would be a negative because that's going to put it in the denominator. So it's going to be about a negative. I don't like that. Negative 1 something. But just know that it's going to be down here. Let me change colors. And come down here. It's going to be somewhere down here like this. Did that change colors? No. It's not wanting to let me change colors. There it goes. It's going to be coming down here. Now if we plug in log 4, 2, that's going to give us what? That is going to be the 1/2. So at 2, it'll be about 1/2. And then if we did 1, it would be 0. And if we do 4, it's going to be 1. Okay, so it's going to look something like this. Something like that. Anyway, you can see that it's reflected over the x-axis, and it's going to be a vertical shift down 1. Or down 1/2, I'm sorry.